Hi everyone, thank you for joining today's session. I hope you had a great weekend and I hope your Monday goes good today. And In the previous session, we have started the WLC and AP concepts. We have completed the wireless module 1, wireless basic foundation module 1. And we have started the wireless access point and the WLC basics. In the previous session, we have looked at the introduction. We have understood the different AP models and also what AP does and the architecture, basically the wireless LAN architecture. The two main components of the WLC or the WLAN architecture is the WLC and the AP. We have understood what is the function of a WLC and what is the function of a AP from the previous session. Later, we are understanding there is a concept in this called as CAPWAP. So what is a CAPWAP? CAPWAP is tunneling protocol that enables communication between the wireless access point and a centralized WLC. So in a WLAN architecture, we have two important components. No matter you deploy the WLC in a cloud, or it can be you deploy a WLC in the cloud, or else obviously the APs cannot be deployed in the cloud and it has to be on the site, right? Or you deploy the WLC on the as a VM in the ESXi, or you have a physical WLC as well. No matter what it is, the AP has to communicate to the WLC through the CAPWAP tunnel, right? That's a CAPWAP tunnel. Hence, it is not it is not required for the AP to be in the same layer 2 environment, but it can have a layer 3 tunnel that is a CAPWAP. CAPWAP was defined in RFC 5415. If you have a hobby of reading request for comment, you can go and refer this 5415. You get more insights how CAPWAP works. But with enhancements such as encryption and better security to its previous predecessor, that is LWAP. Okay, lightweight access point protocol. So CAPWAP are protocols used to manage, control lightweight access points in a centralized wireless network architecture. So once the AP joins to the WLC, it forms a CAPWAP tunnel between them. And it uses something called as DTLS to encrypt this traffic. There are two kinds of traffic that can be put onto this tunnel. That is nothing but the control traffic and also the data traffic. For each of these traffics, there is a separate tunnel for it. And by default, control traffic is encrypted by DTLS and data traffic is optional. Encryption is optional. LWAPP, a proprietary protocol developed by Cisco to manage and control lightweight access points. It's a Cisco proprietary one. The LWAPP headers to tunnel between the AP and the WLC separates control traffic and data traffic. Okay, and the CAPWAP was defined by IETF, that is in RFC 5415. It's an improvement over LWAPP, which is a Cisco's proprietary. It uses DTLS to secure the control channel between the AP and the WLC. So there is a concept of split MAC and local MAC. That is nothing but whether your access point is controlled by a centralized WLC or else the access point is, working as a one, like it takes all the decision. When the access point is controlled by the WLC, so that kind of access point is called as lightweight access point. If the access point can work independently, so then that kind of access point is called as autonomous AP. Okay. And that is what the split MAC and local MAC is. Split MAC is a centralized architecture via the WLC. The data encryption and decryption performed at AP level and the traffic forwarding can happen centrally as well as locally as well in split MAC. In local MAC, everything happens in a single box. And the main benefit of split MAC is roaming. So that WLC handles client mobility. What that means is if you have a WLC and you have multiple APs connected to that WLC, now the client has is connected to a one WLAN, and if he wants to make a transition from one WLAN to another WLAN, so that is possible. And that feature is called as mobility feature. So mobility is possible in a central environment like the split MAC. The client connected to the SSID that is from the one of the access point can move to another SSID in another access point. So that is possible through the feature that is called as mobility, which is available in the centralized environment. Whereas if the access point works as an autonomous AP where it only manages everything, so then it is not possible to move from one access point to another access point when the access point mode is autonomous AP. The benefit of centralized environment is it can perform mobility, it can perform RRM and other features. Radio resource management, which you will learn in the later stages. So that's the benefit of the CAPWAP, where the access point builds a tunnel between where access point builds a tunnel with the WLC and puts both control and data traffic. The encryption and other features, traffic forwarding, and all is taken care by the access point. Whereas the WLC is like a brain of the WLAN infrastructure where it takes care of other important things like if you see the WLC, it will do the authentication, mobility management, QoS policies, frame aggregation, dynamic RF management, that is nothing but RRM. Whereas the tasks performed by the AP are frame transmission to the client. It is the first point of contact to the client where it connects to the SSID. And once it connects to any of the SSID, the client connects to the SSID. Then the client sends the request to the AP and AP forwards that to the WLC and WLC will add that into its client database. That this AP, suppose if it is AP1, this is client 1. So client 1 belongs to AP1. So this will be added into the client's database in WLC. And also it will capture the MAC address and other information and it will add into its database. And depending on what the admin has configured on the WLC, so that information or that configuration will be pushed to the AP and accordingly the client will be registered. So the frame transmission, encryption and decryption, packet retransmissions, so that are done by the AP. As I said in the previous session, the APs are eyes of the WLAN. WLAN is nothing but a extension to the LAN network. Okay, and the brain of this WLAN is the WLC, where it can have multiple APs connected to the WLC and it will take all the real-time information from the AP. It processes by itself depending on the kind of tunneling that you are doing or the kind of modes that AP operates. It can send the data traffic to the WLC or the data traffic can be switched locally from the AP itself and it will be put onto the wired network. For example, If the client is sending some data packets, it comes to the AP, whether the AP wants to put it on the CAPAP tunnel or it can switch from here itself to the wired network. So that provision is also there, which we will learn in the later stages. But for now, you understand that AP builds a CAPAP tunnel for two CAPAP tunnels, one for the control traffic, the other one for the data traffic. Okay, so that's how the CAPAP tunnel works. CAPAP ports are 5246 for the control traffic and 5247 for the data traffic. So these are the port numbers for the CAPAP tunnel. By default, only control traffic is encrypted, as I have said, and it depends for the data traffic, whether if it is bridged to the local network or tunneled to the WLC, and WLC will forward the traffic to the wired network, or AP will forward the traffic to the wired network. There is two options available. So that comes under Flex Connect. We will discuss in later stages. Okay. I hope this is a refresher. In the last session also I have explained this. I just wanted you to refresh the concept. So this is the CAPAP tunneled packet. This is how it looks like. The image is a little blurred, but I hope you can make out what is written here. The 14 bytes of MAC, 20 bytes of IP address, 8 bytes of UDP headers, and then we have the 6 bytes of CAPAP. So the CAPAP, you can see it is sitting above the UDP. Normally, when we have the TLS communication, so we have the SYN, SYNAC, and ACK for the logical connection. But here we don't have that logical connection building up before the communication, before the packets that is being sent. So that's why we have a CAPAP. That's why for the CAPAP we have something called as DTLS. Okay, for ensuring that it is encrypted, and also there is a um, reliability component that should be achieved just like in TLS. So that's why we have the DTLS. So DTLS is a protocol used in CAPAP to secure the control traffic between a wireless LAN and a lightweight access point. It provides encryption, authentication, and integrity for data transported over UDP to provide the same security as TLS used in TCP. DTLS secures the control channel and optionally secures the data channel. The WLC and AP performs a handshake to establish the DTLS session, authenticate each other using certificate, public key, and negotiate encryption algorithms, exchange the ciphers. Okay, so those all things happens in the DTLS handshake. So this particular DTLS handshake will happen in the AP join phase. Okay, that we will learn in the next slide. So now let's start AP join process. So AP join process is nothing but how a AP joins to the WLC. So who gives that intelligence that he has to go and join to that particular WLC? Okay. So let's see the AP join process. I see there is a question in chat. I will take that later and answer. Okay. Let me take the whiteboarding and then explain this. So we have a WLC, then we have access point in our network. So it's connected to a wide environment or the wide infrastructure. Okay. Then how this AP actually discovers this WLC. So once you bring a fresh AP, you just power it on. So once you do the power on, obviously it will go for a power on self-test, and then it will download the image. Okay. Then it starts the AP discovery process. But how does the AP, I don't know, there is a glitch. Okay, now it is back. So how the AP comes to know that it has to go and register to the XYZ WLC. What makes it to go and register to the WLC? So when the AP boots up, obviously it gets powered up. Then it is going to load the software from the flash. And once it loads the software from the flash, there is something called as bootstrap loader. Not only this device, if you take any device, there is an initial program that will be written in the any device. So that is a bootstrap program. So that bootstrap program lets the AP to go through series of steps. So it will start initiating those steps. So what is the first step that it takes? That is nothing but it will do a discovery phase. I don't know why it is losing. So it will go for a discovery phase in the first step. So that particular bootstrap program triggers the discovery phase. So what happens in the discovery phase? The AP must discover the WLC using one of the following ways. So that is, it will send a broadcast in the layer 2. Okay. AP sends a discover request if the WLC is in the same subnet. Okay, if it finds in the same subnet, then it is going to join that WLC. Suppose how it will come to know. So it sends a broadcast packet. So then the AP will send a discovery packet. That's a broadcast packet. Broadcast packet is nothing but the layer 2 broadcast, that is MAC address of this AP, and the destination MAC is obviously FFFF, right? So that is being sent out in the network. When the broadcast packets hits to the WLC, WLC will come to know it's a discover packet. So how the WLC will come to know it's a discover packet? By looking at its packet. So it recognizes that it's a discovery packet and it will respond back. Okay. So that's how it will try to discover. That's the easiest way. If that is not happening, if it is in another network, so then what happens? The DHCP has to provide that information. That is through option 43. I don't know, there is a problem in Zoom. So DHCP option 43. And then we have, suppose if that is also not happening, then it should do a DNS resolution. If that is also not happening, the AP will look for the previously joined WLC, which will be present in its NVRAM, previously joined WLC. So these are the 4 ways through which the AP will learn about the WLC. So once the AP boots up, the bootstrap program it triggers few things. In that, the first thing is discovery phase. In this, the AP will broadcast the packet in the same network, in the L2 network, and it will try to search if any WLC is present in its same network, same subnet. If the WLC is present in the same subnet, then the WLC is going to respond. So what happens if there are multiple WLCs? So whoever responds first, so the AP is going to send a join request to him. And then if the WLC is not in the same subnet, then it will try to get that information through the DHCP server. So obviously, when the AP boots up, it is going to get the IP address. For getting the IP address, it will perform the DORA process. We are all aware of the DORA process. Like it is going to send a discover packet, then discover packet to the DHCP server. And DHCP server, when it recognizes that it's a discover packet is nothing but a layer 2 and layer 3 broadcast it will be having. When it reaches the DHCP server, the DHCP server is going to respond with an offer. So offer contains nothing but the scope of IP addresses that it is having, plus the default gateway and other information. So in the same offer, you can even configure the DHCP server for option 43. So this option 43 will be sent back from the DHCP server to the AP. And the AP takes that information and assign itself the IP, and then it will send request to the DHCP server to give that particular IP. Suppose the IP scope is present from 192.168.1.12 to 1.25. So this is the range that is available. So then the AP will select .13, that is the next available IP, and then it will request the DHCP server to provide that IP. The DHCP server will acknowledge that, and then the AP will start using the .13 IP address. And not only the IP address that it gets from the DHCP server in this process, but also it gets option 43 and many other options. But our concern today is option 43 because that's the IP address of the WLC. So this is how the IP of the WLC is learned by the AP in the second option. If that is also not happening, you have not configured the option 43 in the DHCP server, so then it is going to send the DNS resolution. It will do the DNS resolution. So how it will come to know? It has to contact the DNS server and get the IP address of the WLC. That is because when the DHCP server will provide the IP address, along with that, it is going to provide the DNS IP as well. Okay, or else it will provide the DNS IP as well. So from that DNS IP, it will update the DNS IP address. So now the AP will send the request to the request in the network to that DNS server. So what request it sends to the DNS server? So it has to resolve one of the record, that is nothing but the A record. In the DNS server, we can publish multiple records. So one of the record is called as A record. I think 4 times here, right? So there is one more record that the DNS can resolve, that is called as SRV record. So this SRV record we will learn later, but let's see what is the A record. So A record is nothing but it will if a client is querying for the FQDN, then it is going to resolve that to the IP address, or else from the IP address to the FQDN, it is going to resolve. So what is a FQDN? FQDN is nothing but the host name of the server plus the domain name. For example, the host name of one of the WLC is WLC1 and the domain name is nitishsharma.com. So this becomes the FQDN. So whenever a client request comes with the FQDN, it is going to resolve to a IP address. So that's what the function of the DHCP server is with respect to the A records. When it gives the IP address, it resolves to the FQDN or FQDN to the IP address. So forward lookup and reverse lookup. So that is called as forward lookup and reverse lookup. So in our case, it is going to send Cisco dot capwap dot controller dot domain, okay, to get the WLC IP. So this is the request that it is going to send to the WLC, to the DHCP, to the DNS server. So in its DNS resolution packet, it is going to request to the DNS server for this particular FQDN. So when it receives this, in the DNS server, the administrator has already configured the A record. That is, if some client is coming and querying this FQDN, return him a IP address. So maybe it will return like 182.168.1.13 or 1.31. So this is the IP address of the WLC. So that is how the third option will work, and it will get the DNS from the DNS server. It gets the WLC's IP address. So the next one is, if all the three fails, it is not able to get the answer, then it is going to join the previously joined WLCs. So the AP in its cache, it can have up to eight WLC controllers IP addresses. Okay. So when the access point boots up, so the bootstrap program will trigger the discovery phase. In the discovery phase, it is going to check, it is going to send a broadcast packet in its same network, and it is trying to find the WLC if it is present in the same network. If it is not able to contact any WLC, then it is going to rely on the DHCP. In the DHCP, we need to configure option 43, which is a WLC's IP. If that is also not configured, then the access point, the bootstrap program will initiate DNS resolution. In the DNS resolution, it is going to send the request to the DNS server that it got from the previous step from the DHCP. It is going to contact to the DNS server. In the DNS, we need to put an entry that is called as AAA record. AAA record is nothing but it is going to do a forward lookup that is nothing but from the FQDN, it will give the IP address or IP address to FQDN. But in our case, it is the FQDN to the IP address. So the AP is going to query the FQDN. The DNS will give the IP address back to the AP. So like that, the AP gets the IP address of the WLC. If all the three options are not possible, then the last option is the AP might have registered to previous WLCs. So that information will be present in its database or the NVRAM. So it can hold up to 8 WLCs IP address to which it has registered previously. If you reboot also, that information will be present in its cache. Okay, unless you do the factory reset. So that's about the first step, that is nothing but the discovery phase. Okay, so let's see the second option, second step here. So once it gets the WLC information, so that's the first step. So the next step is nothing but the join phase. So we looked at the first phase here, that is the discovery phase. Now let's look at the second phase. That is nothing but the join phase. So what happens in the join phase? Obviously, we know what is going to happen in the second phase. That is, it has got the WLC information. Information gathering is done. So now it is going to join that WLC. So the AP selects the best WLC, or else you can say the AP is going to send the join request to the WLC to which in the previous step it has got the information about the WLC. It is going to send the join. Suppose there are multiple WLCs in the network and you get a response from multiple WLCs, to which WLC it will prioritize. That depends on many factors. Okay, that depends on many factors. Suppose if a response comes from a WLC, previously it was registered, so then it will give the priority to that. Suppose it depends on like you have the multiple models of the WLCs, and also it depends on the amount of APs a single WLC can register. Okay, to how many APs that are currently registered, it will calculate that ratio. For example, if you have two WLC, WLC1 and WLC2, so its maximum capacity that APs can register is 100. So its maximum capacity APs can register is 100. But now currently only 4 are registered here. Here only 2 are registered. So it will give priority to WLC2. Okay, so that is the kind of uh, that is the kind of uh, logic that it will apply there. Okay, there are multiple factors that can influence the registration of WLC. Okay, as I said, if it is previously registered to some WLC, so then it will give priority to that. In some cases, it will look at the load capacity, and depending on that, it will take a call and it will try to register to that particular WLC. So it all depends when it sends a discovery request. If it receives a response from multiple WLCs, so whichever WLCs it receives a response, so then it is going to apply these logics and it is going to send a join request in the join phase. Okay. So in the join phase, the AP sends a CAPAB join request. The WLC verifies the MAC address, okay, model, certificates. Yeah, certificates are important, right? When you have the certificate, CA signed certificates installed in your network, it's a bit tricky. So normally organizations don't do it, but nowadays because of the vulnerabilities management and all those things, the certificates are a must. So you need to plan the certificates accordingly. So the WLC verifies the AP and responds with a CAPAB join response. Okay, CAPAB join response. So AP sends a discovery request, discovery phase, it will try to find the WLC. And in the join phase, it is going to send a join request. And once the WLC receives it, it is going to check the MAC address, model, certificates, and then it is going to send a join response. So that's the second phase. Okay. So in the third phase, what happens is the third phase is called as the configuration phase. Discovery phase, join phase, configuration phase. In the configuration phase, once joined, the AP downloads its configuration from the WLC, including the SSID, VLAN, policies. So all these things are downloaded from the WLC. We know that in a centralized architecture, the WLC plays the main role where it is the brain of the WLAN architecture, whereas the AP is just a lightweight access point where it is going to forward the frames, then do some encryption, decryption, and then it does the all processing, which is the first step of processing it will do. The decision making is with the WLC. So now when the WLC sends all this information, like what SSID it should showcase, what is the VLAN that it needs to be in, what is the policy that it needs to enforce to the clients. So those all information it will send. So that is nothing but it is going to download that image. And also it depends whether it's a flex connect local switching or central switching. So which we'll learn in the later stages. So depending on that, it is going to send the image. So that image is nothing but the configuration. So configuration image, it is going to send, the WLC is going to send to the AP. So this is what happens in the phase 3. Okay. In the phase 4, it is nothing but the data traffic handling. So data traffic handling happens in phase 4. So once the CAPWAP tunnel is established, then the DTLS encryption should happen. That happens in the join phase. Here it happens, DTLS. DTLS handshake will happen. It is going to exchange the ciphers, the best ciphers that matches that both are using, so that it will use to decrypt all the configuration before the configuration goes out. That is nothing but the control traffic on the port number 5246 when it is going to send that information about the SSID, VLAN and policy and all. So that will be encrypted, because in the previous step, the DTLS is a DTLS handshake happens in the join phase itself. Okay. So once everything is set up, now it is the time to send the data. Okay, that is data traffic handling. The AP starts forwarding client data using one of the two modes. Either it can send through tunneled mode, or else it can send through it can send through like centralized mode, it can send, or else it can send local switching, it can do. Okay. So that this one we will see in the later stages. But what that concept is suppose if you're having a AP and then you are having a WLC. So now that AP is joined to the WLC, AP is registered to the WLC, and now the AP is going to send the traffic, the control traffic and the data traffic. It is going to send to the that particular interface. So that interface is called as AP manager interface. Okay. So that we will learn later. But now it is going to send the traffic to that CAPWAP IP address of the WLC. And that is going to be sent. And now when the traffic of the client, obviously client is going to send some data. It goes to the AP. So AP is nothing but it bridges between the wireless and the wired, right? So either the AP can bridge between wireless and wired, or else the WLC can be bridge between the AP, between the wireless and the wired. Depending on that, there are two modes, either central mode or local switching mode. Central mode, the wireless traffic goes to the WLC, and then WLC will bridge to the LAN network. This is the central mode. In the local mode, the wireless data will go to the AP and AP will bridge to the LAN. So that is the local switching. So this we will learn in the Flex Connect. Okay. But for now, today's topic, it is the AP joining to the WLC. There are four important steps: discovery phase, join phase, configuration phase, and data traffic phase. So these four phases are there, and this is how it is going to work in a nutshell. Okay. So now let's try to see in our lab like how it works, and how a AP works, and how it is going to join and all. So that we will see in the lab. So there are some questions in the chat. This MAC field header in CapApp contains original client MAC, source MAC. Or okay, I will take these questions in the last, so that our flow does not get interrupted. So I previously joined W. So how can we make sure to shift to another WC during migration? So this we can discuss. So now let's check out in our lab how it is going to work. Let me quickly reshare my screen. So I have a 3504 WLC. I know we have not gone through these initial options, but our topic today is just to understand how a AP register to the WLC. So in tomorrow's session, I will give you an overview of all these options that is there. But today our intention is just to understand how a AP register to the WLC. So I have got a AP with me. I have got a WLC with me. So let's try and understand how it is going to work, how it is going to register. So that's the whole agenda. So my WLC IP is 150.1.7.131. As I have told before, there are two models of WLC. The older one is on the Air EOS architecture, which uses 8.x firmware image or the software versions. And the other one is the 9800s, which is going to use Cisco IOS software. So this particular the WLC is a 3504. So when I do a show version, let's see its specification here. I think the show version does not work in this one. Show system info. Show sys info. Here in the show sys info, you can see the model that is this is the Cisco controller. Product version is 8.10 and bootloader version, the bootloader which I was talking about. And here you can see the system name, the IP address that is assigned. So all these things you can see the 802.11b and A. So I believe you are comfortable with this, right? 802.11 is the wireless standard. So B is how much, what is the band that B supports and A supports? Does anyone remember, like 802.11b? So what is the band that it supports? And 11A. So what is the band that A supports? So yeah, you can think about it. So A supports 5 gigahertz, right? And B supports 2.4 only. So you can see so maximum number of APs supported in this 3504 is 150. Okay. And the manufacturer certificate is SHA-1 and SHA-2. And license type is right to use license. It's not a flex license. That's nothing but the smart licensing, right? So it is a right to use license. If it does not make any difference, like it is just a paper license, right? Right to use license means paper license. We are not going to restrict depending on the usage and all. You have to just purchase a certificate and keep it. That's what the right to use license was. So now it is all depend on the subscription based license, flex license. So that's about this device. Let's stick to our agenda. Let's go back here. So now I have this AP with me and this AP version. Let's check out. Admin. AP. So this is a iOS software. As you can see, we are able to log into the privilege mode, but here you will not be able to log into the privilege mode because as it is in the Air EOS 8.10. So here we can run show version here. Okay, and here we can check out the version, what version it is running. So AP running image 8.10. So this is because this particular AP, this is a 3802 AP, okay? Cisco Air AP 3802i. I is nothing but indoor, okay? So this one is running 8.10. So when the AP goes and joins to the WLC, right? So it will download that particular image, AirUOS image. When you register the same AP to the iOS, so then it will run a different image. Okay, when we registered it to a 9800, so that time we can come back here and check what is the image that it is running. So you can see the backup boot image that is 17.16. This is the iOS image. So once it registers to the 9800, so you want to increase the font. Okay, is it visible now? I hope so. Okay, so once you register to a 9800, so then it takes up this backup boot image. So now, since it's registered to a 9,3504, that's a Air OS, so that's why it's taking this image. Okay, that's why we call it as lightweight access point, as it has got no intelligence. All the intelligence it gets from the WLC. So now, so our agenda is to look at the join process. So now I will run few commands through which we will try to understand the boot up process. So let me go here and enable the debugs in the 3504 first. Let me quickly do that because we are having very less time here. So 14, okay, apply. Yeah, debug, capwap, all detail. Okay, detail enable we need to give. Debug, DTLS, DTLS, all and enable. Okay, here I have enabled it. So clear message logs to clear all the messages. Okay. And then I will just do a clear scroll back from here. Debug, capwap. So in the AP, if you want to see what controller it is registered to, so just do a show client, show capwap client config or RCB you can do. From here you can check out the configurations. So now it is registered to the. So one more thing about the join processes, the AP can register up to 3 WLCs. Okay, that is primary, secondary, and tertiary. You can see here the primary controller name, secondary name, and the third name. This is the problem with this. So AP's behavior is, suppose if it does not get any WLC, then it will keep on booting. Okay, if it is not registering to any WLC, so then it keeps booting. Okay, show client. So this is the AP manager IP. So you can see this is the AP IP that is, sorry, WLC IP that it is registered to, that is over 131. Okay. So now I will take the MAC address of this. And there is one more way to run the debug, that is in the WLC, copy the AP's MAC address and run the debug AP debug. Debug capwap. Okay, let's do with this. So I have enabled the debug on both the sides, I guess. Not here in the AP. Come on. Debug. Capwap. Client. Oh, this is for client. Debug. DHCP. Packets. Debug. DHCP. Errors. Okay. Now I am just reloading the AP. So this is our AP. This is our 131 is our WLC. Now let's debug it. Sorry, reload it. Reload. So now let's keep an eye on this in the AP's log. So now it is gone for a boot. It is trying to do a kind of a power on self test where it is trying to find out all the ports that it is connected. It is checking what all things are there. Now you can see checking image signing. So it is trying to download the local image. We might have to extend like 5 minutes more today because need to showcase this. So if we leave in between, so then it will not be useful. Well, it is doing, let me copy your chat. Is the form that is done. Debug Mac add. Yeah, that's the command. This Mac field header in CapApp contains original client Mac or source Mac or AP it's Mac. So it will the source IP source Mac. Uh, so your question basically is whether it will the broadcast packet whether it will have the source MAC. So obviously it will have the source MAC because it does not know the destination MAC, right? So that time it will give FFFF. That's a broadcast packet, layer 2 broadcast. If it is a layer 3 broadcast, the source IP will be 0.0.0. The destination IP will be 255, 255, 255, 255. That's the layer 3 broadcast. When you talk about layer 2 broadcast, it is a source MAC and the destination MAC is FFFFF. So whatever the VLAN or in which network it is, right, it is going to send the broadcast packet everywhere. So here you can see the CapApp state. Now it is initializing. This is the first step. Okay, that is the discovery phase. It is going to send a discovery request to 131 it is sending, 141 it is sending. See, the Discord packet it is having 255. Now it is gone to the join state. Configure, then it is into the run state. This is the last state. AP has joined the controller. This is the name of that controller. Yeah, now it is joined. So let's take copy all to clipboard. Then we go here and here we can understand what is happening. So here it was checking the image. It went for a boot. So it went for a boot. You can see here the bootloader is, it went for a boot. Then it is loading the image. Active version, it loaded an image. This is the backup image that it loaded. Initializing the transmission, hardware specification. It is all checking all the hardwares that it is having. It is checking the radios, all these things it is checking and it is trying to boot. So then what is happening here? It is trying to bring up the channels, what channels it is having. 136, it is for 5 gigahertz, right? Channel 36. Channel 1 is 2.4 gigahertz. It is trying to set the channel. So now you can see AP updated from IP address. IP address updated from 000 to this one. So here boot up process is already sorry, the DORA process has happened, I guess, and then it has got the IP address here, and then you can see DTLS initialization certificate it is trying to use, and the first state. This is the first state that we are having initialization, that is discovery. So now it has sent a discovery request to 131, 141. So then discovery sent to this one. So here it is sending a broadcast in the layer 3. Layer 3 broadcast is nothing but if you open that packet, so in that the source IP will be 0.0.0 and the destination IP will be this one. So that is particularly a broadcast packet. It is, if you see here in the real time, it is sending the request to 131, 141. So this is because it has previously learned. Okay, that's why it is sending. If it is not a fresh AP, right? So that's why it is sending 131, 141, and plus it is sending a discover request also in the, it is broadcasting the discover request in the LAN. Okay, that is also it is doing. Then next what it is doing, then it is discover response it got from 131 and it is got the response from 141 as well. Then capab state DTLS setup, capab state join. So now it is, once it is discovery is done, then the next step is DTLS setup is happening. Once the DTLS setup, then the join process is starting here. In the join, you can see sending join request to 131 through port, you can see 5272. And then join response it got from 131. AC accepted join request, capwap state image data, AP image. You can see this is the backup image. Version is the same, so do not need to update. Suppose if the AP is having a different version and the WLC is having a highest version, so then it will start upgrading. Okay, it goes for an upgrade. No, here you can see no upgrade. Then capwap, the last step is configure. Okay, the last step is configure. So here you can see all the informations related to the AP, what it wants to pass. Now it is just passing it. Okay. So then it goes into a run state. This is the last state where it will start catering the clients or start sending the traffic. So AP has joined the controller and a few configurations, the beacon rate. So all these things are, beacons are nothing but it is going to send a keep alives for some particular time. Okay, this is what happened at the AP end. So now let's look at the WLC end. So timed out, I guess. In the show message log, I don't see much logs got captured here. So you can see the Kappa app manager, the system is unable to process primary discover. Let's go back. Show message. Here, when you see it, so the system is unable to process requests from interface on VLAN 150. It is trying to get something. Then there's a capwap error, capwap error, then DTLS closed error. I don't know why there is the DTLS connection closed for AP101 and then did not receive heartbeat reply. The system is unable to process primary discovery response. Where are the messages after this? So this is because we put a reload, right? So that is why it came. The messages are printed till this point, but the messages after that for the joining one, I don't know why it's not showing. Show history. Show debug. Specific client debug. Debug institute. Why the debugs are not there? So this is the command to disable the debug in this. There are different commands, okay? I just try to make a note of it, like when I enter, or else I will share that in the notes. Mm. Okay, that's all the messages I can see on the WLC, but there should be more messages. I think we need to enter the debug MAC address of the AP. So then it will give more messages. But since we did only the debug cap app all, so it didn't give much messages in the WLC. But to understand the join process, we ran few debugs on the AP, so that gave the clear understanding of how the AP is going to join. So this is a scenario when the AP was already registered to the WLC. But when you bring a fresh WLC and you do it, the messages will be little bit different, but the process is same. Okay, but the way it goes and register, it is little bit different. So if possible, I will try to showcase the DHCP, the DORA process also, but it is little bit tricky. But we can do it for the client. When the client is trying to register, we can run a Wireshark in the client machine and then we can try to check out. So this was basically how a AP goes and register to the WLC, a high level process and also the messages. In the next session, we will try to go through the configuration that is there in the 3504. Okay. And then we will understand all the tabs here. Then we will understand how to implement this out of the box. And then we will learn about the 9800 and we will look into the GUI different options that it has got, important commands like that, and then we will go for the client registration. So first step is AP registration, where we register a AP to WLC. The next step is the client registering to the WLC. So that's the two steps we have. But in tomorrow's session, I will walk you through the GUI options that we have got here. Then we will learn about the 9800 and also how to deploy it. What is the difference between the VM and also the actual appliance that we have got. So we will explore that part. I will walk you through the data sheet and different documents through which we will understand what are the different models, how they have to be installed. Okay, those things we will understand in tomorrow's session. And also, if possible, we'll try to register a client, create a WLAN and other configuration. Before registering a client, I want to explain you how the configurations has to be created first, right? So then only we can register a client. So that's the third step we need to do. So first we have learned the join process now of the AP. Then we will learn about the configurations, basic configurations. Then we will register the client. Okay, that's the third step that we are going to do. So I will share this file with you. Okay, in that so basically that monday.com, right? So that is having some issue. So there is one more app that we are using now, that is Notion. So I will share you the links. You will get the invite similar to what you got for the monday.com. So that I will share with you in some time. There I have updated all the topics and the due date and the completion date of how it was in monday.com. There I will add these files also, and this file also I will add it into the in that particular portal. Okay, there is a change in portal. I will share that information to you. The AP used UDP port 5272. Yes. So it will use sometimes 5242. Some devices will use 5272. But in the books it is like 5247. But in practical it uses 5272. Okay. I will take all these things, paste it here. Shahrukh, remaining questions, I will just try to answer in the initial tomorrow, or else if you want to stay back, I can just explain that. But I think I will take that tomorrow. Okay. So today almost the time is done. So I will explain this to you before the class or after the class tomorrow. Today I have to complete one work. So tomorrow I will explain you that. Please hold your questions. And also, if possible, I will update in that particular portal that I'm going to share. There I will post this question and I will answer each question and I will keep. Okay. And one more thing I want to tell is, like, once the labs are completed, so please do the labs by yourself. Try to explore all the debug commands that are there. I might be missing one or two because in 1 hour of time showing everything might be not possible. So I might not put one of the debug commands and not show you that. So try to enter all the commands, explore everything, how it is working in the back end. So use all the tools that are available and try to understand. If I'm missing on anything, please highlight that. I will explain it one more time.